In this lecture, we will talk about definition of the trigonometric functions in a unit circle. So it's still about definition. Before we do this, let's recall what we did before. The first definition we got for sine, cosine trigonometric functions is we define sine in a right triangle. Okay, so we say sine theta is the opposite side over hypotenuse. So it is B over C, or opposite side over hypotenuse. Okay, so we have a saw. Yeah. And cosine is car. Okay, so it's adjacent over hypotenuse, and tangent is opposite over adjacent for tangent. That's in a right triangle. That's the first definition we have. And then we move this triangle, okay, the vertex of this triangle theta, we move this one to the xy coordinate plane, okay, and then this theta. So we can extend our definition in a right triangle for any angles. Okay, so then the sine will be defined as y over r. Okay, y over r. And then the definition comes to be, then of course cosine is adjacent x over r, and tangent is y over x. Okay, and here is what we got. See, y over r. Y over r is sine, cosine is x over r, and tangent is y over x. The rest of the three is just the reciprocal of the above. Okay, that's the definition when we move our triangle to the xy coordinate plane and the angle is in the standard position. Okay, means the vertex is on the origin of xy coordinate plane. Okay, today we like to restrict this r to 1. Okay, we like r has a special value to 1. Then that will be our topic. You see, if r equals 1, then that's 1 y over r. That's 1 y over 1 comes to be. So then sine theta is going to be y. And if r is 1, then x over 1 is going to be just cosine theta equals x. Okay? And then tangent theta is still y over x. Okay? So the definition comes to be like what? It's going to be like this. Okay? So since r is 1, you see right here, r is 1, so y over 1. So here is y over 1. So we don't need to write 1, we write sine t is y. And then cosine theta is x over 1. So cosine t is x over 1. We don't need to write 1. And sine t is y over x. And here is y over x. There, the angle was theta. And here the angle, we like to use t. Theta equals t. Okay. Previously, we used theta as an angle. Now we use that theta equals t. So we replaced theta with t. And cosecant t is the reciprocal of above. You see, y over 1 comes to be 1 over y. Yeah, x over 1 comes to be 1 over x for secant t. And cotang, here was y over x, and here is x over y. Okay, so those definitions all are consistent. The only difference is here r may not be 1, but here I is 1. Okay, I is 1 make our life easier. We don't have denominators. Okay. Now, so in this graph, r is 1, restricted to 1. Then you know x coordinate is this part, y coordinate is this part. So y over 1. So basically the length of y is just the value of sine t. And the length of x, or the x coordinate of this point, x coordinate of this point P is going to be cosine t. Okay, and then the ratio y over x, so that would be tang t. This length over this length is going to be tang t. Again, the rest of them just choose the reciprocals of the above. So since we have introduced this definition, of course, which are consistent with the previous one, then we will discuss more in this lecture about the radius r is 1. Okay, you will see we will have many good features starting from this point in trigonometric function. So from now on, r equals 1. Okay, don't consider other values. So please remember we did 3 steps. In right triangle, and then move the right triangle to the standard position with the vertex and origin, and here r can be any value. Then we restrict r to the special value equals 1. All those 3 definitions are consistent. The only thing is that the first one is only defined for acute angle. Okay, then we got problem with 0. How are we going to define 0? Because 0 is not an acute angle. So then we define for any angles after we move the triangle to the from here to here to the xy coordinate plane, and then we like to restrict r to be 1. All those are consistent. Okay. All right. When we did this example, we considered some special angles. Recall that in the right triangle here, if we have this acute angle is 30 degrees, then the opposite side is the half of the hypotenuse. Okay? So that's why, we have here is radical 3. So you may mark 1, 2, radical 3. Radical 3 squared is 3, 1 squared is 1, add together is 4, but 2 squared is 4. So 1 squared plus radical 3 squared is 2 squared, which is 4. Okay? So remember, you may mark those values on your rulers. In this way, you don't have to remember the special values for sine. Remember that? You see here, what's the sine? Sine 30 degrees is 1 over 2. Okay? Is 1 over 2. And then sine pi over 6 is 30 degrees. That's 1/2. Okay? And then sine 60 degrees is opposite side over hypotenuse. That's radical 3 over 2. So that's why we have here radical 3 over 2. So this ruler is going to help us. Okay, remember that. And then, for this one, 45 degrees, 90 degrees. Yeah, you may mark those two legs, 1. Okay, and here will be radical 2 hypotenuse. Because 1 squared plus 1 squared is 2, and radical 2 squared is 2. Okay? So then, sine 45 is 1 over hypotenuse. Yeah. And then in this case, you may write 1 over radical 2 is 45, sine 45, okay, which is pi over 4. Okay, so remember those two rulers. You probably should have those two rulers. Okay, those special values can be found by using rulers. That's my point. All right.